Welcome. Let me step through these Chapter 2 exam practice questions for you. So number 1, we have shopping times in minutes for a random sample of 16 shoppers. And we're going to complete just the first 2 rows of a grouped frequency distribution using an initial class boundary of 15.5 and a class width of 4. So let's start there. 15.5 is our initial class boundary. And a class width of 4 tells us that to get to the start of the next class, we would add that width of 4. And that will bring me to 19.5. And then each of these classes has a lower boundary and an upper boundary. And these 2 values will always be the same. So the first class has an upper boundary of 19.5. And then we can always find this ending value by, again, adding 4. So that would be 23.5. All right, so our boundaries end in 0.5, but I'd like to work with whole numbers because the data are in whole numbers. So we're going to look at shopping times and their class limits. So these are called the boundaries because the values inside of them will be the limits. So inside of these boundaries as a whole number, after 15.5, if you think of a number line, the next whole number would be 16. And staying inside the boundaries before 19.5 on a number line, you would hit the whole number 19. All right, and then once you have those 2, you can just add 4 again, or you can go through that same process with the second class. I'm just going to add 4. So 22, 23. All right, I had to be careful there for a second. Okay, now we're ready to look at our frequencies. So we're going to do some counting, count all the shoppers that spent between 16 and 19 minutes, and all the shoppers between 20 and 23. So I've gone ahead on my calculator and just entered that data. So you don't have to sort the data. I just prefer to. So I've entered the data there in L1. So I'll do stat and sort in ascending order. And I'm sorting list 1. And now when I go back and look at that list, all those values will be in order. And if I highlight L1, I'll see the values across the bottom. So highlight L1 and hit enter. Now my cursor will be at the bottom. And you can always check out the YouTube video on sorting if you have not done that yet or just need a review. So now that the numbers are in order, it's making it easy to count values from 16 to 19. 1, 2, 3, 4 of them. And then values from 20 to 23. Looks like just 2 of them. All right, so if we did the whole table, we would have to have 16 values, but just to save space on the paper here, just showing you the technique, and we'd continue if we wanted to go ahead and make a frequency distribution of all the data. All right, number 2. So now what we'd like to do is focus on interpreting histograms. So before I do this particular question, I just want to point out here that with our histograms, we really want to focus on the y-axis and what information is provided. So we'll either get frequency, like here, a frequency. So this would be a count of how many of something, versus on number 3, the y-axis is relative frequency. So that would represent a proportion of something. So we want to focus on that first, and then let's check out these questions. All right, so for number 2 here, they're looking at projectors in classrooms, and they're talking about how long the light bulbs last in hours. And first it says, what was the sample size? So how many bulbs were included? So we have the frequencies for each of these bulbs. So for example, 7 light bulbs lasted somewhere between 750 up to and not including 800 hours. And then 15 bulbs were from 800-hour lifetimes up to, but not including 850. So we've got the frequencies. So I'm just going to come over here and remind you that sample size is lowercase n. And if we have the frequencies, we can just add them up. and that will give us our sample size. So I'm going to just head over to the calculator here, and I'm entering the values at the top of those bars, and we're going to end up with a total of 50 light bulbs in the study. All right, so we want to focus now on the difference between B and C. B is how many light bulbs in the sample have a lifetime of at least 900 hours versus what proportion of bulb lifetimes in the sample are at least 900 hours. All right, so let's go to this phrase at least first. So at least 900 hours would be 900 hours or more. So I'm just going to indicate that up at the top here. So that would be those bulbs. So that's at least 900 hours. So if it says how many, we would just add those frequencies. So in total, the frequencies for those two classes, 9 plus 4, we have 13 light bulbs. All right, versus relative frequency. So a proportion represents a relative frequency. And for that, we take the frequency, the count, and we say out of how many. So in other words, we divide by our sample size. So I don't want to just know it's 13 batteries. I want to know 13 out of how many. So that's our proportion or our relative frequency. And then it does say in the directions we want to do percent form. So nothing wrong with fractions, but the directions indicate percent. So I'm going to divide there and write the decimal first. And then move the decimal 2 places to the right. And I'll see then that that's 26% of light bulbs. Okay, let's just do a couple more here. So what proportion, so I'm just going to write relative frequency again. So proportions are always relative frequencies. And this time we want bulbs that lasted less than 800 hours. So here's my 800 mark. So now we're interested in those light bulbs. So because the axis is labeled frequency, and these are whole numbers, we know that this is counting light bulbs. So in this case, it would be 3 plus 7 out of, because we want proportion, out of those 50 bulbs. Okay, so that is 10 over 50. And again, you can use the calculator to change that into decimal. And then just be careful when you move that decimal 2 places to the right. You're going to have to fill in that missing digit with a 0. So that's going to be 20% of light bulbs. Okay, so that's proportion. The next one is how many. So how many bulb lifetimes in the sample have lifetimes less than 800 hours? So that's just asking for the frequency. And we did that already, the 3 plus 7. Oops, sorry. 3 plus 7 is 10. And I'm not writing units here, but that would be 10 light bulbs. All right. So let's see how that compares to number 3, where we still have our histogram, but now the y-axis is relative frequency. So now what you're going to see is these values at the top of the bars are in decimal form. So we know it's not frequency, or they would be whole numbers. And that's another way to know we're talking relative frequency. So proportions. All right, so we are looking at information from a study of methadone clinic patients, and they're looking at their daily dosage of methadone, and there are 250 patients in the study. All right, let's go proportion first. What proportion of patient dosages, patients have dosages less than 100 milligrams? All right, so 100 on the graph over there and less than that. So again, that's relative frequency, proportion, and they've already given those values in decimal, so we don't have to do any dividing like we did above. The information is already given in its proportion form. All right, so we'll just take 0.24 plus 0.28, and that's 0.52. And we're going to go ahead and write that as a percent as well. So whatever the directions would say, it's always good just to practice. So 52%. All right, and then what proportion of patients have dosages of at least 200 milligrams? So at least 200 would be 200 or more. So that would just be this proportion of patients, 0.04. And again, proportion, so that's already relative frequency. And again, we could write that as a percent as well. Okay, and now it says how many patients have dosages of at least 200 milligrams. All right, so in this case, we're going to need to know how many patients are in the study. We can't tell that from the histogram, but they do tell us here in the given information, 250. So the proportion of patients that had dosages of at least 200 is 24%. So we need that proportion, 24% of those 250 clinic patients. All right, so we're just doing our proportion of a value. So we can take the percent and write it in decimal, 0.24. And then if we multiply that by the frequency, we will get our total patients that meet that condition. So 0.24 times 250. So it looks like we've got 60 patients with dosages of at least 200. So if that axis was labeled frequency, we wouldn't see 0.04, we would see 60. Okay, let's end here with one other type of graph. So the stem and leaf display here is looking at test scores, and they tell you how to read it. So the stem, the number on the left side of the vertical bar, is the tens column because it says that the 6 there is 60, and the ones column is our leaf. And so 6 and the 0 indicates a score of 60. So I'm just going to write down actually both test scores there. So the stem 6 with a leaf of 0 is 60, and a stem of 6 with a leaf of 6 would be a score of 66. So that's why we call it a stem and leaf, the bigger part of the number, and then the ones column are the leaves. All right, so let's go with what is the highest grade overall. So that would be in the 90s, and the biggest leaf is an 8, so highest score is a 98. How many grades are in the 80s? So we could write them all out, but the point of the stem and leaf is to condense the information. So I'm just going to say them out loud. There's a score of 82, a score of 83, a score of 84, etc. So if I count the leaves, 1, 2, 3, 4, 5, 6, 7 leaves, that means there's 7 scores in the 80s. And then find the range of the scores. So just a reminder here, range of a data set is the highest value minus the lowest value. So our highest score we already got there was 98. And the lowest score is, we already wrote that down as well, 60. So that's a difference of 38. So that's called a measure of spread, the range. All right, and then finally, we have a measure of center here. So the mode, remember, is the data value that occurs the most, or the data value that occurs with the highest frequency. So looking at my stem and leaf, I'm seeing those repeating 2s. So there's a 72, a 72, and a 72. So 3 people got a 72. And also I'm seeing here 5 is repeating 3 times, 85, 85, 85. And those would be the 2 grades that occur with the highest frequency. So they're both occurring 3 times, and no other grade repeats that many times. So we actually have 2 modes. So 72 and also the 85. Okay, so hopefully that helps you a bit with your chapter 2 exam practice.